All right, for all those people that are here today, class. Today, what's up, my dude? You have a good break? Okay. All right. Angel, you good? All right. So, properties of definite integral. Now, we're going to use properties definite integral to solve for some stuff. And I have been adding a little bit of steps already into this. So what we're doing today is basically going to be what we've already done in the other sections. Property definite integrals, properties 1 through 4 in section require a function to be integratable. So you have to be able to take the integration of that. Say that two theorems guarantee a function f is integratable, a function that is continuous on a closed interval and is integratable from a to b. So it has to be able to take the integration on a, what type of interval is that? Closed. Okay. Function that is bounded on a closed interval, a to b, and has at most a finite number of discontinuities. Now, what does finite mean? Limited number of discontinuities. So we could still do this with like piecewise functions. So, integral the sum of two functions f and g are integratable on a closed interval from a to b. Then we could actually break up this and this. We could break up the two different into separate integrations by themselves. That's going to be key because one of our fundamental theories of calculus is going to be based on that. But you're not going to be given a function, you're just going to be given what that answer is. Wait, you all right?
Yeah.
Zoning out a little bit. Okay, I got you. Okay. I know it's Monday after a long break. So, use this property. So, use the property what I just told you. So, rewrite this first. So, you people, right now, rewrite this. So, if I rewrite it, it's going to turn into the integration from 0 to 1 of x squared dx minus integration from 0 to 1 of e to the x dx. And this is normally going to make our life easier because we're going to get some complicated problems that we need to actually separate them anyway. So it's going to make life easier. All right, right here, integrate that. That's going to give me x to the third over 3 from 0 to 1 minus e to the x from 0 to 1. All right. Top minus bottom.
Oh, yeah, minus.
Yeah, it's top minus bottom. So that's going to give me 1 over 3 minus 0 over 3. And that's going to be this first piece here. The second piece, minus, I put a bracket right there, that's important, because that's going to subtract all of what I have in the next one. Okay? E to the x, what's the integration of e to the x? E to the x, right? So that's going to give me e to the 1 minus e to the 0. Anything to the 0 power is 1. So let's go ahead and I'm going to do a little bit of distribution here because why not? that's going to make that one a minus, and that's going to make that one a plus. Yeah, it's just e. But it's kind of like a really good habit to get into to remember what it is all the time. It's always like having a one in front of the number. It's implied that the one is there. So you have minus e, and then plus one, right? Oh, okay. So together, that's going to give me 4/3. So 4/3 minus e. Make sure. Do we go all the way to 3? All right. Next one. Integral of a constant times a function. So one of the constants that we're going to have is going to be, a lot of time we do it with like circles, so we usually throw that pi out in front of the integral. So that pi is a number and is a constant. So whatever factor I could take out of this, it makes the whole taking my integration a whole lot easier. So whatever I factor out of it makes life easier. This one, what can I factor out of that? Yeah, not the x, because the x has to be part of the interval, because it's only the constant, which is the 3. I can't really factor out a variable, because I have to do the integration with that. So that's going to give me 3 integral from 1 to e and 1 over x dx. All right, integration 1 over x. ln, very good, very good. Now, to remember the trick, if I were to do this, it would be x to the negative 1, wouldn't it? And what do I always do when I take the integration? Add 1 and then divide by that number. So that would become x to the 0 over 0, which doesn't work, right? So if you try to do it like that and you see that, be like, oh yeah, that should jog your memory that this is going to be an ln problem.
Would it be ln of absolute value of x?
Yes, ln absolute value of x. Why is it absolute value? It doesn't exist in the negative, right? If you look at the graph of ln, it doesn't exist to the negative ever. Yeah, it's all positive. So, but for this one right here, we're going to have a definite integral. So if I were to actually do it on paper and I was actually having just a integral, okay, not a definite integral, which actually has numbers and bounds, and I'm just doing a basic integral, I would include the absolute value bars, okay, because whatever I decide to plug in later, I have to remember. Late? You all right? You all right? Okay. So I'm worried about you kind of zoning out. All right, so that's going to be 3 bracket ln x, right, from 1 to e. All right, so I'm going to have 3. What is ln of e? 1. ln of e is 1 minus ln of 1. What is ln of 1? 0. Very good. ln 1 is 0. So that's going to be 0. So this is going to give me 3 which is just 3. Hey, Helmy, did you grab the notes? You still writing it down? Okay. Alrighty. So, example 3. This thing looks like a hot mess, doesn't it? Yeah? Looks kind of like a hot mess, doesn't it? I don't like it. So, I'm going to rewrite it. Right now, what is my common denominator? 2x. So, I'm going to rewrite it with a common denominator. So, all of them are going to have the denominator of 2x. So, I'm going to go integral from 1 to 2 of 3x cubed over 2x minus 6x squared over 2x minus 5x over 2x plus 4 over 2x dx. Yes, now we're going to simplify. Because that's going to help me out, because we really don't have a quotient rule for integration. We just divide it out. All right, simplify. So still integration from 1 to 2 of 3 over 2x squared minus 3x minus 5 over 2 plus 2 over x dx. So if I wanted to, I could break it up like we did on the first example, but I don't think that's going to be necessary here. We just do each integration individually, right? And then we just take it all together. So each term we integrate. So integration of 3 over 2x squared is going to be let's do the variable first. So it's going to be x to the third, right? And then divided by, but it's still times 3 over 2, isn't it? Okay. So hopefully writing it like this might be helpful to see what's happening. And what's going to happen right there? 3 is going to cancel, right? Okay. So I'm just writing it out step by step for you. Minus. That's going to give me 3x squared over 2. And this is going to give me minus 5 over 2 There is no variable there, so we add 1, right? Yeah, because we add 1 to the variable that's not there. And then this next one's going to be plus. What do we get for that one right there? What do you got, Blade? 2 ln x? Yeah, that's it. Yeah, that's fine. From 1 to 2.
So for the x cubed over 3, do you always have to separate it?
No, I'm just showing you that because we're doing a couple things and this is going to cancel that, right?
Wait, but how would you do it if you didn't separate it?
Are you saying 3 over 2x cubed over 3 like that? I would just cancel out those 3's. If I already know it's dividing by that, or I can go 3 over 2x cubed divided by 3 over 1, right?
Yeah, how would you do that?
Okay, is it fraction over fraction?
Yeah.
Okay, what do we do if it's fraction over fraction?
Okay, yeah, so then you would call
So it turn into 3 over 2x cubed
yeah.
times,
And then that would cancel. Okay.
still cancel. Yeah. Alright, I don't want to try and squeeze it all down here, so I'm going to move this to the next one. So it's going to be 2, right?
On that same question that Allison asked, can you also take like the numerator like by itself, like do like 3x squared, and then like take the integral over of that?
Are you talking about this one right here? Just do this by itself?
Yeah, the 3x, no, the 3 over 2x squared.
3 over
On the
2.
second part. The same thing that
Right here?
yeah. But you also do like 3x squared and then find the integral of that, but like multiply it by 1/2.
1/3. 1/3. Remember, you add 1 to the exponent
No,
first.
I know that, but I mean like you're like doing 3x squared and then you're finding the integral of that, right?
Like that?
Uh-huh. And then you do like add 1 and then over 3.
Yeah.
And can you multiply that by the 1/2 as well?
So for this right here, you're taking the integral of this, or you have this right here.
Yeah.
So are you asking about taking the 1/2 out of like the entire thing?
Like you do that first, and then you can multiply by 1/2.
Give me 1 second. Let me go back to the problem right here. So you're saying right here, instead of putting everything over 2x, do 1/2 out here.
No, that's not. Can I show you?
Yeah, come on up.
It's not all that complicated. It's just like I was just asking if you can do like
Just go to the next page over.
I'm just asking if you can do like so the original one was 3 over
2 x squared.
squared. I was just asking if you could basically just instead of that you can do like 3x and just ignore the 2 and do this over 3, but then like multiply it by 1/2. Can you do that?
Yeah, same thing. So yeah, it means the same thing. So it's just you're putting the 1/2 out front of that.
Yeah.
It's the same thing, and so when you put it together, this is still going to cancel,
Yeah.
and you're still going to be left with x cubed over 2.
So I can always like separate.
Yeah, you can separate it like that.
Okay. Alright, that's all. Thank you.
All right, so we're doing top minus bottom. So we're plugging in the 2 now, right? So we're plugging in the 2. So it's going to be x cubed over 2 minus 3 over 2 x squared minus 5 over 2 x plus 2 ln x. And all this is my top, right? Minus the bottom, and the bottom here,
Why is it minus?
because it's always top minus bottom. So the bottom piece would be, it was 1, right? Yeah, it's 1. So it's going to be 1 to the third over 2 minus 3 over 2, 1 squared, minus 5 over 2, 1 plus 2 ln of 1.
Are we subtracting?
Yes, we will subtract. So if you notice, I have them in brackets for the top part minus the bottom part. So I'm going to do the math for the top right here. So that's going to be what? 8 over 2?
4.
That's 4. Minus, that's going to give me 6 minus 5 plus 2 ln of 2. Minus the bottom, which is going to be 1/2, minus 3 over 2, minus 5 over 2, and plus 0. Because ln1 is going to give me 0, and 0 times 2. This over here, I'm going to end up with negative 7 plus 2 ln of 2 minus the other side, which is going to give me, let me see, what's that going to be? Negative 8, negative 7 over 2? And minus minus becomes a plus. And so that is going to be what? 14 over 2. Yeah. Negative 14 over 2. And 7 over 2 is going to give me a negative 7 over 2. Yeah.
3 over 2 plus.
This one here?
Yes.
It would eventually, but I'm doing the math here. So it's negative. So they're all common denominators, right? So if I add them together, I get 3 and 5 gives me negative 8, right? And positive 1 is negative 7. So negative 7 over 2. But I'm not distributing this until the very end right here. You guys got it down? All right, so we got about 20 minutes left of class. So the first set of problems, we got it all ready, you have the tools to do first set of problems, which is the homework. I'll put it back up on the board here in a moment. Anyone questions before I keep going? Or before you guys get to work?